Let's start off with a question. Let's imagine that you and I are on a network where they've set up a DHCP server, and so it's handing out IP addresses, default gateway, DNS information to clients. Clients are all happy, but then one day somebody either maliciously or accidentally plugs in a device that's acting also as a DHCP server. And now some of the clients are getting an IP address that is not the right subnet. They're getting a default gateway that leads somewhere else, possibly to the DHCP server, and that's a huge problem. It could be a disruption of service for sure, but it also could be the beginning of a man-in-the-middle attack. So as a solution to that, wouldn't it be awesome if we could set up a structure or some type of security that protected DHCP services, so that if somebody did bring in a DHCP server that was non-authorized, whether it was on accident or whether it was malicious, the switch could just step in and say, you know what? No, I'm not allowing any of your DHCP server stuff today. We can do that with a feature called DHCP Snooping on a Catalyst switch. And to provide a backdrop for how DHCP Snooping works, let's imagine this network where we have the legitimate DHCP server sitting right here plugged into port 3/3, and then we have three clients, client 1, 2, and 3 off of these ports respectively. And let's imagine this is subnet 10.16.20 with the 24-bit mask, and the default gateway is 10.16.20.7. So these clients, when they boot up, if they're configured to use DHCP, they'll do the DORA process. They'll send a DHCP discover. The server will send the offer. If there is a server that hears that request, then the client will request that, and then the server will send an acknowledgement. So some of these packets that are involve the client piece, and some involve the server piece. So with one authorized DHCP server and no unauthorized DHCP servers, life is good. But the moment somebody intentionally or accidentally plugs into that VLAN a DHCP server, if that DHCP server hears a discover message, it's going to give an offer. And if the client accepts it and requests that IP address, we then have a client with misinformation about what the default gateway is, what the subnet is, and so forth. So here's how we solve the problem with this feature called DHCP Snooping. We configure the switch and we tell it to pay attention to DHCP server type messages like the offers, acknowledgements, and there's a few others, but they're all server based. So once we enable this feature and we say that we want to use this feature on VLAN 30, the switch starts listening to all that and says, you know what? The answer is just say no. Just say no to what, Keith? Just say no to any DHCP server type messages like offers and acknowledgements. Just say no on every single port in that VLAN. And then the question is, well, what about the real DHCP server? Doesn't he need to do offers and acknowledgements back into the network so the clients can see them? And the answer is yes. So what we do is once we've enabled DHCP snooping and we've applied it to the VLAN, we would then take the ports, and I'll circle this one right here. We take the ports that lead to the real DHCP server and we say, I trust you. From a DHCP snooping perspective, that would be a DHCP snooping trusted port. And as a result, those DHCP server type messages are allowed into the switch on that port because it's a DHCP snooping trusted port. And that way, all the other ports on this switch, including 10, 11, and 12, if they start acting like a DHCP server and start doing offers and acknowledgements and so forth, the switch, because by default, once this feature is enabled, DHCP snooping, all the ports that are not explicitly trusted, like 3.3, all the other ports are explicitly non-trusted or untrusted ports from a DHCP snooping perspective, and that way no rogue DHCP servers will successfully get on your network because all the other ports by default are untrusted and the switch just simply won't let that traffic in. And that, my friend, is the concept behind DHCP snooping. It basically says every port, once the feature is enabled, every port is not trusted unless we specifically trust it, and we trust only those ports that lead to the real and authorized DHCP servers. And that way, bogus DHCP servers cannot be introduced to our network by connecting to any of the other ports on the switch. So in the very next video, we'll take a look at some of the commands and configurations to implement DHCP snooping. And then as we continue together, we'll do additional labs on both configuring and verifying that DHCP snooping is working. So I'll see you in the next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.